welcome you all in this NPTEL online certification course on mechatronics. I am Pushparaj Mani Pathak, Professor Mechanical and Industrial Engineering Department, IIT Roorkee. I will be taking this course for you. As we all know, these days many of the mechanical devices come with the electronics control. So, basically mechatronics, the name as indicates, it is electronic control of mechanical system, and these days mechatronic devices are available all around us, whether it is industry or it is your home. There are we come across many mechatronic devices. So, with time, more and more such type of devices are going to come, and we are going to be user of all such devices. So, the aim of this course is to enable students aware of the mechatronics technology, what are the various components of mechatronics, and ultimately we would like to design our own mechatronic system. Okay. So, our course will be basically going through something like this. Initially I will be discussing the content of my course, and then we will take up the introduction part, that is which is the topic of discussion in this lecture. So, in introduction we will be seeing introduction to mechatronics and mechatronics approach, what are the measurement system, what do you mean by the control system, and what do we mean by the microprocessor based controllers. So, these things we are going to see under mechatronics. Then the one of the important components of any mechatronic system is sensors. Okay. So, we will be discussing a lot about sensors and transducers, and we will begin with what are the various performance parameters or terminologies for sensors. Then we will be looking at the photoelectric transducers, flow transducers, optical sensors and transducers, semiconductor lasers, and various other type of sensors, and what should be the selection criteria for selection of a sensor for a particular application. So, all these things we will be looking at, and then we will be looking at many other mechanical and electrical switches, input data, inputting data by switches, and yes, and various other form of sensors we will be looking at. Next, we will be seeing the actuators and mechanisms. As we know, actuator and mechanisms are basically the component of any mechatronic system which basically gives the motion, okay, or the one which is a source of power. So, here in this content we will be looking at various actuation systems, pneumatic and hydraulic systems such as say process control valves, rotary actuators, mechanical actuation systems, and electrical actuation systems. So, these are the various actuation systems which are going to be associated with one way or other with a mechatronic system. Okay. So, we will be looking at all these. So, after actuation and the sensing, we will be looking at what do we do with the signals which we get from the sensors. Okay. So, there is a dedicated section on the signal conditioning. whatever signals we are getting from the sensors, we need to condition those signals, because those signals may not be appropriate to be used for the control purpose, okay, or to be suitable for the controller. So, here we will be seeing the signal conditioning, filtering of the digital signals, the multiplexers, how do we acquire the data, that is we will be looking at the data acquisition system, and we will be looking at further the digital signal processing, pulse modulation, and the data presentation system. So, these are some of the things which I will be covering under the signal conditioning section. Next, these signals are to be processed or sent to the controller. So, we will have a dedicated section on microprocessor and microcontroller, where we will be looking at the control, and we will also be looking at the micro computer structure, microcontroller applications, and the PLCs, that is the programmable logic controller. So, these are the things which we will be looking at. Now, these in design of mechatronic systems, before we actually make the system, it is always to better to model the system and see the system response, okay. Then we actually go for the making of the system, or manufacturing of the system, or assembly of the system, or whatever way we want to make it. So, here we will be looking at the mathematical models, and these mathematical model corresponding to various, say, mechanical system, electrical system, hydraulic system, thermal system, we will be looking at, and we will be seeing the dynamic response of these various mechanical, electrical, hydraulic and thermal system. Then to analyze these systems, we will be looking at the transfer function and the frequency response approach for analyzing these systems, and we will be also seeing the closed loop controllers here, and MATLAB as a development tool. So, I will be touching a little on this, and we will be seeing how can we use the MATLAB as a tool for the simulating the system. And the final outcome, which is the desire of all of us to design a mechatronic system, okay. So, here we will be looking at design and mechatronics. So, what are the various input output systems, then computer based modular design, system validation, if once we have designed, how do we validate the system, then remote monitoring and control, designing, what are the various possible design solutions, and we will be taking up few case studies for that. Here are some of the books which you may refer to enhance your knowledge further. These books are a very popular book on mechatronics by W. Bolton, which is published by Longman, and Indian edition of this book is available. Then we have another very good book, Introduction to Mechatronics by D.G. Alciator and Histen, which is being published here in India by Tata McGraw-Hill. Then we have another book, Mechatronic System Design, but by Devdas Shetty, Kolk and Richard. Then there is another book by Bishop on Mechatronics Handbook, in fact, which has come from the CRC press, and there is a book, another book which has been co-authored by me. It is on intelligent mechatronic systems, modeling, control and diagnosis, okay, which has been published by Springer London. So, you can take up, you can refer any of these books to supplement your learning of this course. So, let us begin the course. coming to the introduction, first of all let us see what is the definition of mechatronics, how various people see mechatronics, how do they define. So, the Yaskawa Electric Company in their trademark application document defined mechatronics as the word which is composed of mecha from mechanism and tronics from electronics. So, this is how they decomposed the mechatronics by splitting it in the mecha and electronics basically. Okay. Or in other words we can say that the technologies and developed products which will be incorporating electronics more and more into the mechanism intimately and organically, and making it possible to tell where one ends and whether where the other begins. There is another definition given by Harashima, Tomizuka and Fukuda in 1996. They said that mechatronics is the synergistic integration of mechanical engineering with electronic and intelligent computer control in the design and manufacturing of industrial products and processes. Another definition given by Oslander and Kempf is that mechatronics is the application of complex decision making to the operation of physical systems. Shetty and Kolk in 1997 said that mechatronics is a methodology used for the optimal design of electromechanical products. The Bolton defines mechatronics as a system defines mechatronics as the system which is not just a marriage of electrical and mechanical system, it is and is more than just a control system, it is the complete integration of all of them. So, mechatronics is generally recognized worldwide as a vibrant area of study these days. There are various undergraduate and graduate programs in India and abroad on mechatronics engineering. There are many courses offered in universities, and there are many dedicated referred journals are available which publish papers related with mechatronics, and there are many conferences which are held worldwide in this area. So, with this brief, if I ask what a mechatronics is, what the mechatronic system is. So, basically we can say that it is the implementation of electronic control in a mechanical system, which we call as the mechatronics, and this enhances the mechanical design with electronics control, and there are many places where we are able to replace the mechanical component with the electronic solution. Here I will take an example of real life application of mechatronics. In the figure we can see there are two that is the household thermostat. Okay. So, there are two pictures you can see. The left picture is the thermostat which was used earlier, and in this one the concept of mechatronics were used, and the one which is shown in the right, that is the one on which the mechatronic concept has been implemented, or what you can say is that the right one is the mechatronic solution of the thermostat. So, here is the thermostat which was used earlier. Here say we want to control the temperature. So, for that first we need to know the current temperature. So, we have a thermometer to tell the current temperature, and based on the current temperature we would like to set a desired temperature. So, there used to be a dial to set the desired temperature, and we have a sensor or a switch, whatever we call it, and then there used to be a heating unit. So, this is the earlier design of the thermostat. Now, if we want to convert this design thermostat components, the earlier design into a mechatronic design, then here we can see in this slide. So, let us decompose these things. So, for the user feedback we have a say thermometer, and for input by the user there is a knob. Then again the feedback is fed through a dial, and then there is a temperature sensor, and there is a switch to turn on heater. So, these are say 1, 2, 3, 4, 5, these 5 are the mechanical components. Now, if I want to replace this with a mechatronic design, then we can see that for the feedback, user feedback, we have LCD display for the user feedback, and for the user input there are tactile switches with up arrow and bottom arrow indication with the aim to increase the values and decrease the values. Then the temperature sensor is there, which is TC1047A, which can be used as a temperature sensor, and switch to turn on the heater, a MOSFET can be used for that purpose, and we can have a regulated power for there, and then for the control purpose we can use PIC 16F913. So, all these component integrated basically gives us the mechatronic solution, and the outcome is what we have seen. So, this is what the finished design is. Here you have the current temperature in the LCD display, and there is a desired temperature in the LCD display, and we have the tactile switches for changing these values. So, this is the mechatronic solution, and this is how the finished design is being seen over here. Now, we can classify the mechatronics products, okay, based on what extent and what stage mechatronics is being implemented. Okay. So, in the late 1970s, the Japan Society for the Promotion of Machine Industry classified mechatronics product into 4 classes. Okay. So, the class 1 is the primarily mechanical products with electronics incorporated to enhance the functionality. So, mechanical products there they incorporated electronics to enhance the functionality, and the examples include say numerically controlled machine tools and variable speed drives in manufacturing machines. So, this was the class 1 type of mechatronics product. The class 2 type of mechatronics products are basically the traditional mechanical system with significantly updated internal devices incorporating electronics. So, their internal devices has been updated with the use of electronics, and the external user interface are unaltered. So, external user interface is as it is, and the example include say the modern sewing machine and automated manufacturing systems. So, these are the class 2 type of mechatronic products. The class 3 type is the system that retains the functionality of the traditional mechanical system, but the internal mechanisms are replaced by electronics. Okay. We see the digital watches. These days we have the digital watches which has replaced the mechanical watches which used to be earlier in 70s and 80s, and as well as we can take the example of say alarm clocks. Okay. Earlier there used to be the spring loaded alarm clocks, and these days we have the entire mechatronic solution of that, where we have the digital alarm clocks. Okay. So, these are the class 3 type of products where the internal mechanism has been replaced by the electronics. Then we have another class called class 4 type of products, where products are designed with mechanical and electronics technologies together, synergistic integration. So, synergistic integration. Okay. So, these examples includes your photocopier. You see the photocopier, we have mechanical system and we have electronic control. I will be coming very much in details in my next lecture when I will be talking about the examples of the mechatronic system, but let me tell you, the photocopiers are one of the best example of the mechatronic system. As well we have the intelligent washers which we used, all of us may be having the washing machines in our houses which are the completely mechatronic system. Dryers are there, automatic ovens are there, all these are very good example of a class 4 type of mechatronic system, where the mechanical and electrical technologies have been thoroughly synergistically integrated. Now, the enabling technologies for each mechatronic product class illustrating the progression of electromechanical products in stride with development in control theory, computational technologies and the microprocessor. Now, as I was telling you, the class 1 products were enabled by the servo technology, power electronics and control theory. The class 2 product which I discussed in previous slides were enabled by the availability of early computational and memory devices and custom circuit design capabilities. The class 3 products relied heavily on the microprocessor and integrated circuits to enhance the mechanical system, and the class 4 products marked the beginning of true mechatronic system through integration of mechanical system with the electronics. So, as I told you, say the dishwasher or the your washing machine or your photocopier, these are very good example of the mechatronic system. It was not until the 1970s with the development of microprocessors by the Intel Corporation that integration of computational system with mechanical systems became practical. The electronic ignition system was one of the first mechatronic system to be introduced in the automobile in the late 1970s. In fact, the automobiles, our cars are best example of the mechatronic systems, where either we have say the automatic door closer or the door closure through a remote. Basically, we give the signal and there are actuators which close the door, or whether it is the ignition system, or you can say that the power steering. There are many more examples which we can talk about the mechatronic system application in the cars. And these days we have Google cars coming, or the futuristic technology where people are working on the autonomous driving or say driverless car. So, that driverless car is complete integration of the mechanical and electronics, and a very good example of the mechatronic system where we can see that there are so many sensors there integrated, so many actuators integrated over there. There are microprocessor, microcontroller to implement the control actions, and all other subsystems related with the mechatronic components are there. Historical development, before we begin with further with mechatronics, let us see the historical development, how with time things have changed, and that will give us a really good feel of how things have progressed in this direction. So, before 1900 there were pure mechanical systems, say we can say steam engine which came in 1860, or dynamos which came in 1870, circular pumps which came in 1880, combustion engines which came in 1880, mechanical typewriters, tool machine pumps, all these things were there till before 1900. Now, with increasing application of electrical drives, so we can see that in 1870 came the DC motor and 1889 came the AC motor. So, with increasing electrical drives, what we came across is the mechanical system with electrical drives. So, you can see in 1920 and we have the electric typewriter, okay. And then came say the relays, solenoids, hydraulic, pneumatic, electric amplifiers, and PI controllers, that is proportional integral controllers, came in 1930, okay. And then in 1935 we have mechanical system with automatic control, we can see the example of steam turbine. So, basically this is an era of increasing automatic control, okay. Then came transistors in 1948 and thyristors in 1955. So, we this led to the mechanical system with electronic or analog control and sequential control. So, in 1955, and what we came across is electronic control lifts. Then further digital computers came 1955, process computer came 1959, real time software 1966, microcomputer 1971, and digital decentralized automation 1975. So, here you can see that there is increasing automation with process, computers and miniaturization. So, basically with this we came across mechanical system with digital continuous control and digital sequential control. This is an era of 1975 and the applications were machine tools, industrial robots, industrial plants, disk drives and all. Then came the microcontroller 1978, personal computers 1980, process, field bus system, new actuator sensors came, and integration of components was made available possible. So, we came with the mechatronic system, okay. And here integration of mechanics and electric hardware is there, software determines functions, new design tools for simultaneous engineering is there, and there is a synergistic effects are there. So, examples here you can see the mobile robot, computer integrated manufacturing, magnetic bearing, and the automotive control. So, here increasing integration of process and microcomputers. So, basically what we can see that the factors which have been responsible for the development of the mechatronics, these are basically inventions on the electrical drives, then increasing automatic control, increasing automation with process computers and miniaturization, and increasing integration of processes and microcomputers. Now, let us see what are the benefits of mechatronics, why we want to go for mechatronics. Okay. So, the primary reasons being there are more features, higher precision, user friendly, more flexible, lower cost efficient, environment friendly, smaller geometry, that is miniaturization is there, things are more reliable and things are safer. So, this slide summarizes the mechatronic system components. Okay. So, here basically we can see the mechanical systems. On mechanical systems basically we have the actuators and sensors. Actuators could be say solenoid, vice coils, DC motors, stepper motor, depending on what application you are interested, stepper motor, servo motors, hydraulic and pneumatic actuators. Then we have the sensors, that is the switches, strain gauges, potentiometer, thermocouple, photoelectrics, accelerometer, digital encoders and MEMS. Then the signal of sensors, they are to be conditioned. So, we have the input signal conditioning and interfacing is there. Here we have the discrete circuit, amplifiers, filters, analog to digital and digital to digital converters are there. Then these signals are fed to the digital control architecture, where we have the logic circuits, microcontrollers, SBCs, PLCs, sequencing and timing, logic and arithmetic, control algorithm, communication. Now, these digital control signals to be suitable for actuators has to be processed again. Okay. So, we have the output signal conditioning and interfacing. Again here we have the digital to analog converters. For example, the control signals from the digital control architectures are digital signals, whereas the actuators they actually take the analog signal. So, we need to have a digital to analog converters. We may also require digital converters, we may require the power transistors, amplifiers, power op amps and PWMs, and many times we also like to see our output signal. So, we have the graphical displays which could be in the form of LEDs, LCDs, digital displays or the CRTs. Coming to the system, here basically when we are talking about mechanical systems. So, as I told you in beginning of my this lecture, we before actually making or designing the system, we may like to see the system models and the dynamic response. So, let us let us see what a system is basically. So, we can think of system as a box which has a an input and which has an output, and where we are not concerned with what goes inside the box, but we are rather concerned with the relationship between the output and the input. So, here we can take example of say a motor being a system, the input being the electric power to it and the output being the rotation of the motor shaft. Okay. So, this way we define the system. Now, measurement systems are basically a black box used for making measurements. It has the input, the quantity being measured, and the output, the value of that particular quantity. Okay. Examples could be the temperature measurement system. Here is an example of the measurement system, where we can see that we have a transducer which is say thermocouple. Then we have the signal processor, the thermocouple signal has to be processed. These signals are actually very weak. So, we need an amplifier to amplify these signal, and then this signal being analog, it need to be converted into the digital one. So, we need one analog to digital converter and digital decoder, and then this digital signal can be given to a recorder which is nothing but a LED display. So, this is how a measurement system consists of. So, we have thermocouple as a sensor, there is a signal conditioner and there is a display. Now, a control system consists of again say an input and output. Input is basically say if we are talking about central heating system. So, input is what the required temperature is, and the output is the temperature of the set value. These control system could be open loop system or closed loop systems. The open loop system basically has got no provision of feedback. Okay. So, here that system which we talk about, the central heating system, basically in the open loop mode it could consist of say a switch and an electric fire. So, through switch basically we input the decision to switch on or off, and this switch basically supplies power to the electric fire, and the output is the temperature change. So, this is the open loop system. We do not have control over the temperature over here. Okay. So, this is an example of open loop system. There is no provision of feedback here. Now, if we talk about the closed loop one, then what we do here is that from electric fire the output we take that output through a measuring device, as you can see, and we feedback this temperature signal to the comparison element, where the input, that is what required temperature we want, that is, and the feedback value, they are compared, and a deviation signal is found, and that deviation signal is given to the switch, and again that switch supplies power to the electric fire. So, this is an example of the closed loop system, where we can see that there is a provision of the feedback of what the actual output temperature is. Now, here basically if we talk in general term, so we have a control unit, we have a correction unit, and we have a process. Okay. And the control variable of course is taken from here through the measuring device, and the measured value is given to the comparison element where the error signal is found. So, the example of this closed loop system, a very good example of closed loop system is the soft speed control, where we can see that say there is a motor here, and we tap the output speed of the motor. So, with the help of say a bevel gear arrangement, and that the shaft of the bevel gear drives basically a tacho generator, and the voltage which is given, the output of the tacho generator is basically in the form of voltage, and that we compare with the DC supply, that is the potentiometer value which sets the reference value, and this difference signal is given to the differential amplifier, which does amplifies difference between the reference and actual value, and then it drives the motor. So, this is the system for the speed control of the shaft basically, and here we can see that there is a provision of the feedback, and that feedback is done with the help of a tacho generator, which acts as the measuring device basically. So, in a block diagram form I can explain this. We have an amplifier which amplifies this error signal basically, and then that signal is given to the motor, and then motor in fact through motor we get the rotation of the shaft, and then we measure the output speed of the shaft with the help of we take the feedback with the help of tacho generator, and that is given to the your comparator here, where it is compared with the reference value. Okay. So, with this I would like to conclude this lecture. Thank you for listening.